Hey everyone, welcome back. Let's have a look over our new sensor. It's a bit accelerometer, let me tell you, and it is AIS328DQTR. And let's have a roll up on the website that will be controleverything.com. And here we have to search on for this particular sensor, and let's see what we got here. And we see it as a high performance, ultra low power 3-axis accelerometer. And also you can see a lot of much proficient features as shown in front of you, and also as a plus point you can purchase the sensor right from here. Just add to cart and you are ready to go. Furthermore, I will be interfacing the accelerometer AIS328DQTR with a BeagleBone Black, and the software platform will be the C language code. And let's go to resource tab, and here we can have the C code sample onto the screen, and you can download the code as a zip file right from here. And also you can get the code from the repository that will be Control Everything Community, and it is from the website github.com. Now what we require is to have a look upon some connections for the hardware we will put together. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen. And this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this I2C shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this, and gently insert it over here. It is very useful to power up the BeagleBone Black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. Now we require our high performance 3-axis accelerometer AIS328DQTR, and this here is a connecting cable. Now make sure the connection among the sensor and the cable and the ground terminal of the sensor should be connected to the ground wire of the cable, and similarly to the ground of I2C Shield. Now we are done with the connections part. Let's move on to the interfacing of the code, and let's see what we got there. Coming to the interfacing part, first of all we need to log into github.com, and after that we have to search on for the repository that will be Control Everything Community, which you are able to see on my screen. Let's go, and here we have the sensor AIS328DQTR, and this comes the C code, but let's have a look over the instructions first. In this part, we have to set up the BeagleBone Black, as you can see, and the instructions are on this link, beaglebone.org. And when I open it up, you can see a lot of steps that need to be taken care very precisely and carefully, and do it. And after that, we have to download the code onto the BeagleBone Black, and this command will compile, and this will run the C code. Please note it down. And after this is the C code, it's a .c extension file, and in the code you notice that we have included some of the header files and the libraries, and in the void main function we are going to create an I2C bus and check whether it is going to open or not, and the address of the sensor is 0x18. Coming to the writing section part, we are going to select control register 1 0x20, that is the address, and we are going to send a command for X, Y and Z axis enable. Power on mode, data rate output will be 50 Hz. That will be 0x27. As you can see, the writing command is here. Then in the next writing command, we are going to select control register 4 0x23, and we are going to send a command for full scale plus minus 8G continuous update 0x30 is the address, and then we have a sleep function for 1 second delay. After that, we are going to read 6 bytes of the data, but one by one. And as you can see, LSB for X axis, first of all from the register 0x28, the acceleration data, then so on so forth, the data for y-axis and z-axis. After that, we have a conversion of the data takes place here, which you can see as the acceleration for 3 perpendicular axes x, y and z. We have used the formulas and the information provided in the data sheet for AIS328DQTR. At the bottom of the code, we have the output data to be printed onto the screen, which means the acceleration in x, y and z axis. It is actually the raw values which might be negative, might be positive depending upon the acceleration at that present time. So this is how the code is. Now let's see how it works. Now let's have a look over the working part, and for that stuff to go on, we need to copy the entire code as you can see on my screen. Copy it, and after that we have to open up the terminal, and here we have to create, as you can see on my screen, this is the file. .c will be the name and extension file, and paste the entire code, and after that we need to save the code, and after that this is the command for the compilation we need to go it through, and here we go, the code has been compiled. But when I try to run it, this is the command, and we have the acceleration in x, y and z axis, and when we run it, there is a very small change regarding the raw values of the acceleration in all three perpendicular axes, because there is no motion in the sensor. But when I try to move the sensor in different directions, you can see a significant change in the raw values regarding the acceleration in all the three perpendicular axes, x, y and z, and the values are onto the screen which you are able to see. So this is how the sensor responds. Now let's have a look over some of the features, benefits and the applications regarding this sensor. The AIS328DQTR is an ultra low power high performance 3-axis linear accelerometer with a digital serial interface SPI standard output. An I2C compatible interface is also available. The device features ultra low power operational mode that also advanced power saving and smart sleep to wake up functions. The AIS328DQTR has dynamic user selectable full scales of ±2, 4, 8G and is capable of measuring accelerations with output data rates from 0.5 Hz to 1 kHz. The applications are telematics and black boxes, in-dash car navigation, anti-theft devices, intelligent power saving, impact recognition and logging, motion activated functions and a lot more. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.